Okay, students, I'm going to do a summary of everything in Unit 11 dealing with quadratics, okay, and how I would teach it. If you're taught by somebody different or watch other videos, this is how I would do it. All right, so Unit 11 is on graphing quadratics. So first you have to know what a quadratic is. Standard form of a quadratic. Ax squared plus bx plus c equals 0 or equals y or equals the f of x. Okay, why is this a quadratic? Quadratic means degree 2. When I look at a polynomial, polynomial is made up of one or more terms that have a variable in it. So in this case, x. The highest degree of any of the terms, there's one term, remember terms are separated plus or minus signs. So we have 3 terms on the left side, 1 on the right side. Okay, so this degree, we did this at the beginning of the year, is to 2. This degree, called the linear term, is degree 1. This degree, the constant term, is degree 0, because I can write x to the 0. So when the highest degree of any of the terms is 2, as it is here, ax squared, that is called a quadratic. It will graph into what's called a parabola. That could open up or down, is all we're going to deal with in Algebra 1. But technically, they could open left or right as well. Okay, yours are only open up or down. Okay. Now, what's going to determine the shape of how wide or how narrow? I could have a quadratic like this, or I could have a wider quadratic. What's going to determine if it's wide or narrow? It's the A, the leading coefficient. A is called the leading coefficient, okay, because it's the lead term, and it's the coefficient of that lead term. Remember, when you write in standard form, no matter what, whenever it says to write your answer in standard form, it means from highest degree down. So degree 2, degree 1, degree 0. So the leading term is ax squared. The leading coefficient is a itself. Okay, the leading term is ax squared in this case. Okay, in your example right there, negative x squared would be leading term, and the leading coefficient would be negative 1. So that's our negative 1 right there for leading coefficient. Okay, the shape of the graph is all determined by this ax squared. The bx and the c shift the graph left, right, up, or down. But the shape of the graph is determined by what the variable in the, or what the a is for the leading term. So if a is greater than 1, it's going to be narrower. Okay. If a is, you can say greater than 1 or less than negative 1. Okay. It's going to be narrower. If a is between 0 and 1, I mean between negative 1 and positive 1, okay, any fraction or decimal between negative 1 and positive 1, that is wider, also called narrower. Okay. Now this can be written, this one right here, can be written as the absolute value of a is less than 1. This inequality right here can be written as the absolute value of a is greater than 1. So this is what this right here means this. This is the long way of writing it out. This right here means this. This right here is the longer way of writing that out. Okay. So between negative 1 and 1, it's wider. Greater than 1 or less than negative 1, it is narrower. All about the A right here. Okay. Now, what determines whether it opens up or down? If A is positive, opens up. If A is negative, less than 0, it opens down. Okay, that's simple. I just look for the A. A is going to tell me the most. The quadratic term, this is called the quadratic term. The quadratic term tells me the most about the quadratic itself, the shape of the quadratic and whether it opens up or down. Okay, remember that's called the linear term. And constant term. Okay, now hopefully you've heard a lot of this already when you're dealing with factoring. And we talked about that then, you remember it, but if not, you're getting it retaught all again right now. You need to get those memorized, those terms, because on the DCAS, they might just ask what's the coefficient of the quadratic term, or they might say what's the coefficient of the leading term, or they say what's the coefficient of the linear term, or what's the constant term itself, just that number. So you have to know that. Okay, you could get asked, how do you determine whether the quadratic is wider or narrower? So you need to know both of these setups. Those are equal, and those are equal. You don't know which form they're going to put it in. So you have to know what each one is equal to. Okay, and then we're going to look at it. You're going to have to know whether it opens up or down. Just look at A, positive up, negative down. Okay, so that's the beginning, okay, of understanding something about quadratics, and now we'll get into some more details. So I now have to erase all that because now I'm going to be graphing here in just a second. So if you haven't copied it all down, pause the video and copy it down. Okay. So this first example, they've given it to you in standard form. Remember, ax squared plus bx plus c equals 0 or equals the f of x function notation, which is the same thing as y. Okay. It could be written as y equals negative x squared plus 4x plus 12. There's no difference, except for the form and that it tells you it's going to be a function. Remember, function definition of function, for every x, there's only one y, and it must pass the vertical line test. That's the advantage of putting in function notation. You can know that about the graph now. So therefore, I know when I graph it, it can't go like this because that would fail the vertical line test. So being that it's in function notation, it must pass the vertical line test. All right, so when we factor, it's going to come into two factors. Okay, that's just a general idea of what a factoring looks like. Okay, we always want to have our leading coefficient, in this case the negative one, we want to be positive. So we're going to factor out the negative, and you're left with x squared minus 4x minus 12. Dang it. Minus 12. Now we go ahead and factor that. Remember, it must multiply to AC, which is 1 times negative 12 or negative 12, and add to B, negative 4. And so those two numbers are negative 6 and positive 2. That adds negative 4 and multiplies 12. So I have negative. I cannot forget to drop that negative down. And I get x. We know the first term times this first term has to multiply to x squared, because that can only be x and x. And then I just fill in the negative 6 and the positive 2 because these both are ones. If they weren't ones, then you use the Carlson method or AC method or box method and factor correctly. You have my method of factoring. You should watch that video as well for when the leading coefficient is not 1 to remind yourself how to factor. Okay, so that's now factored form. Okay, on the DCAS, they could give it to you in any form. They might give it to you in standard form one time, factored form another time, and vertex form, which is going to be our third example we look at, another time. You have to be able to identify the graph or graph it from all three ways. Now, we've already identified that it opens down from the leading coefficient being negative 1. Okay, so if it opens down, that's going to be a max. If it opens down like that, for example, obviously that value is a max. Now, don't forget, when we're talking about what that maximum is, if they ask what the maximum is, it's only the y-coordinate. So make sure you make a note. Max or mins are only, not the y-intercept, the y-coordinate of vertex. So that's called the vertex. This right here is called the vertex. Okay, that's not what this particular graph is. I just quickly drew that right there. That's the vertex. The maximum always occurs at the y-coordinate of the vertex if it opens down, or if it opened up, it would be a minimum at the y-coordinate of the vertex. So that's a minimum on that one. This right here is a maximum. What's the maximum? It's the maximum y value. Okay, that's the highest y value in the entire curve. This is the lowest y value in the entire curve. This is not, these are not two lines, these are curves. All parabolas are curves. Okay, so remember, if it asks for where does, what's the coordinates, meaning plural coordinates of the maximum value, then it'd be the x and the y. But if it just says what's the maximum value, that's only the y coordinate. You must know that. You do not put down the x and the y. And we'll see that in one of the problems I have coming up as well. Okay, so now we have that. You understand max and min. Now, what are the other, okay, so we have this factored form right here. Now, remember from factoring, anything on the x-axis right here, every y coordinate is 0. X changes all along here, but the y coordinate is 0. So that's why we would set this equal to 0 for the y coordinate, because remember f of x is like y, and we go ahead and set each factor equal to 0. Remember, that's a -1. We can't set that equal to 0. Remember, from our factoring chapter, we only can set factors that have a variable in them equal to 0. Okay, so we'd have x minus 6 equals 0, makes it 6, comma 0, and x plus 2 equals 0, so x equals -2. So -2, comma 0. Remember, we write them as points because we're plotting them. Okay, so now we're going to go ahead and plot these. So we have 6, 0, and -2, 0. Okay, the y-intercept, as I pointed out here, the y-intercept, remember, anything on the y-axis, every x-coordinate is 0, and then whatever the y is, 0, 10, 0, 14, 0, 8, 0, 0. So all I do is stick in 0 for the x. That's why I have 0 automatically in there for the x. Plug 0 into the equation. 0 there wipes it out, 0 there wipes it out, and you get 12. So 0, comma 12. It's always going to be your constant term because the variables are going to get wiped out when you plug 0 in. So 0, 12 is the y-intercept. They asked that. Okay. Now, we're not going to answer this one next. Point symmetric to the y-intercept because we have to get the line of symmetry first, or axis of symmetry. Sometimes called line of symmetry, other times axis of symmetry. That equation is negative x equals, it's an equation first off, so it's x equals, and it's always going to be a vertical line since our parabolas are opening up or down. So a vertical line always has the equation x equals a number, right? X equals a number for all vertical lines. You should know that from Algebra 1. And how am I going to get that number? I'm going to plug in negative b over 2a. Remember from our ax squared plus bx plus c. There's my b and there's my a right there. Leading coefficient is a, linear, that's the quadratic term. The linear term's coefficient b is my b. So I plug in, and this is from the original up here, and the original. Okay, so negative b is -4. Another word for negative is opposite. So the opposite of b is -4 over 2 times a, which is -1. So I have -4 divided by -2 is +2. So x equals 2, and I don't have room to write it, clear right there. X equals 2 is my axis of symmetry. It's a line. Notice I'm dashing it. Why am I dashing it? Because it's not really there. It's not part of the equation. But that's going to help me come up with another point that they want on here in this point symmetric to the y-intercept, if you were to ask that. You may not get that asked at all in the DCAS, okay? I'm not focused on that, but that's just because I'm going to show you how I would graph these in just a second without even using that at all. But in these problems, if I was giving you this worksheet, and that's what the flip math is using, they want that. So this axis of symmetry is also called a line of symmetry, okay? A reflection line is also called a reflection line in geometry. What's a reflection line? A reflection line means whatever's on one side, it needs to go perpendicular to that. That's 90 degrees. It's a perpendicular symbol. 90 degrees to that line and the same distance away. Whatever this distance is, that's a congruent sum hash mark means the same distance. So I have one hash mark and one hash mark. That means the same distance away. You don't have to draw this out there. I'm just showing you and teaching you some geometry right now. So equal hash marks, 1 and 1 means those are the same distance. These are vertical. These are perpendicular symbols, 90 degrees. So notice how far this is from here. That's 2. So I must go 2 out to the other direction. That would be the point symmetric to the y-intercept, since that is the y-intercept right there. 0, comma, whatever that is, 12. Okay, which you have right there. So what is this point right here? 4, comma, 12. Okay, so there's my point symmetric. 4, comma, 12. Notice that is exactly halfway. Okay, the axis of symmetry is halfway. See, x equals 2, this x equals 0, this x equals 4. They're both 2 away from that line of symmetry or axis of symmetry. Okay, equal distance. The y coordinate doesn't change. It's only the x. The line of symmetry is x equals 2. That'll be halfway in between. Now, is there another way I could have got that instead of doing the negative b over 2a? Is there another way I could have come up with this line of symmetry? Yes, there is. If I look at my, that's the quickest way. Usually you just do negative b over 2a. But if you have the factored form, or you are able to figure out the factored form, and you are confident you had done it right, if you're not confident you can factor accurately, then you better be using that negative b over 2a every time. That's going to be accurate every time. You may not be able to factor. If you're not good at factoring, you might have blown your factored form, and then if you use those coordinates, you're going to be wrong. So this is a double check, a way to check it. I use the negative b over 2a to see if I get that same answer. Now, if I'm using these x-intercepts, remember those are also called roots, zeros, and solutions. Okay, so x-intercepts, roots, zeros, and solutions. Okay, those are the 4 names for your x-intercepts. These 2 blue dots across the x-axis. You gotta know all 4 names. It's the line of symmetry is always the midpoint, the line that will go through the midpoint of it. So how far is it from -2 to 6? That's a total of 8. What's half of 8? 4. So I can go back 4 this way, or I can go forward 4 this way. And this is the midpoint right there at 2. So that's my equation right here. X equals 2. This is the other way that you get your axis of symmetry. If you're given the factor form, you take the midpoint, draw a vertical line through that midpoint, and you know all vertical lines are x equals, and then whatever that midpoint is, 2. That's exactly what you'd get when you plug in the negative b over 2a. Okay, so this is a guarantee the negative b over 2a is going to work. You may or may not have factored correctly up there and come up with the wrong x-intercepts. So this is a backup. If I apply negative b over 2a first, and I know I've confidently done negative b over 2a and got negative b over 2a and I got x equals 2, and I dash that line x equals 2. That way, if I do that first, which is the smartest way, if you're not totally confident with your factoring, then when I factor and come into the factored form up here, and I get my 2 factors and plot those, I can now check if I did them right, because that line has to be the midpoint of the 2 factors. So let's say I screwed up and I said it was x minus 2. Let's put this in green. Let's say I thought it was x minus 6 and x minus 2 on my factoring. I messed up. I don't know I messed up, but I just did. So then you're thinking that it's x equals 2. And so you're going to plot 2 here, and then halfway between that 2 and the 6 would be 4. And you would have thought the axis of symmetry is 4 if you went by the midpoint. Okay, but because I went ahead and did the negative b over 2a first and got x equals 2, then I know this axis of symmetry must be the midpoint. So if I have these 2 answers, that means one of them is wrong or both of them are wrong, because the midpoint has to be at x equals 2. Okay, so that's a way for you to check also that you haven't messed up on your factoring. Okay, that line of symmetry must be, the x coordinate of that must be the midpoint. Okay, next, that is also where the vertex is going to line up on this axis of symmetry, which means this axis of symmetry, I do the negative b over 2a, that is the x coordinate of the vertex. That's why you see this written right there. This is x comma y. So the x coordinate of the vertex is the expression negative b over 2a. It has to be along the axis of symmetry that we have right here. Okay, axis of symmetry, that x value is the x coordinate of the vertex. Okay, so I go ahead and plug that in, which I did. I got x equals 2. That means 2 is the x coordinate of the vertex. That's my negative b over 2a. So to get the y coordinate, I just plug that 2 into the equation. Okay, into my original equation. Now, the only reason I say original is because if you messed up your factored form and you plugged it in there, which you can if you do it right, and I'll show you that in just a second, but if you messed up your factored form and plugged it into that one, you're going to get a wrong y coordinate. That's why you always want to plug it back into the original. Okay, you can double check it if you want with, and we will in just a second with the factored form, and then I should get the same answer. If I do, then I probably factored correctly. That's another way to guarantee that you factored correctly as well. Okay, so number x is 2. Plug it into this. So I'm finding the f of 2 now. Okay, so remember that's 2. So that's just like saying find the f of 2. Because I already did the x coordinate and got 2. So the f of negative b over 2a is just the f of the x coordinate. The x coordinate we already found to be 2. So we're doing the f of 2. Now I have, when I substitute in, I need to put parentheses around this. AJ and others, plus 4 times negative 2 and plus 12. I'll go ahead and erase this now. Okay, so let's plug that in all in one line now. Negative of negative 2 squared plus 4 times negative 2 plus 12. Always put parentheses around. Never forget this in all your math classes. When you substitute in, you put parentheses around it. We talk about this all the time from day one in this class here. PEMDAS, order of operations, exponents come first. So negative 2 times negative 2 is 4. But now I have that negative 1 out front times 4 is negative 4. 4 times negative 2 is negative 8. And then plus 12. Okay. And what do we got wrong here? 2, negative 4, negative 8, it's negative 12, plus 12 is 0. Hold on here. That does not make sense here. Oh, what am I doing? Okay, I said the f of 2 and I plugged in negative 2 for some reason. I don't know what I was doing. I was going to say that doesn't make any sense. Can't come out to 0. It's got to be up here. Whoa. All right, caught my error. So I didn't, okay, so how did I know I messed up before even when I got that 0? Because this curve goes through those points, these 2 points, so the vertex has to be higher up, somewhere up here, to have it come down. So I have to get it up there. So I got to plug in 2. Okay, so 2 squared and then plus 4 times 2, not negative 2. Okay, that's all right. You plug in the right number this time and you're going to get the right answer. So that's 2 squared is 4 times negative 1 is negative 4 plus 8 plus 12. So I get 20 minus 4 is 16. So 16 right there, 2 comma 16. So 2 comma 16 is my vertex. Okay. Now I've got, you always want ideally 5 points. You want the vertex graphed. You want 2 points on each side of the vertex. There's 1 point on the side of the vertex. So there's 1 point. Here's 1 point, and here's the other point. Notice these are also, that distance is the exact same as that distance, and again at that 90 degrees. That's a reflection line or line of symmetry. Okay, they have to be equidistant. Notice I went 2 hash marks for geometry because that means they're not the same as these 1 individual hash marks up there. Those 2 are the same distance. These 2 down here are the same distance. Just know that for geometry. Learn some geometry terminology now. And always at 90 degrees for reflection lines. Okay, so I go ahead and graph my curve. I know it can come down like this going through those points. Go a little wider like this right there. Okay. And there's my curve. My parabola opens down. Why did I know it opened down? Because again, I knew that right away because that leading coefficient is -1. So I knew it opened down, which is right here. Opens up or down? Opens down. Okay. A was less than 0. So make sure you make a note of that when you just say down, say A is less than 0. That's why you know it opens down versus up, A would be greater than 0. I've got those right here written for you. Okay, now that is all the information that you need on this. Oh, wait a sec, right here. Do they have that? No, yep, that's all the information you need right now off of this. For this right here, we've answered every question. Okay, now we're going to go on to another one. All right, so this time they gave me in factored form to begin with. So I know my x-intercepts that each of these factors equal 0, and I get -3 comma 0 because the y is always 0 for x-intercept, right? The y-coordinate is always 0 every time, and that one gives me -5. So I plug -3 and -5. It opens up because I multiply this together for standard form, multiply them together. I get x squared plus 8x plus 15. So that's 1, so I know it's going to open up. The leading coefficient is 1. Remember, that's the A. That's what A equals. Okay. The y-intercept, I plug 0 in for x, and I get 15. Okay, so 0, 15. The point symmetric to the y-intercept, we have to get the axis of symmetry first for that. Okay. So we've got that fill in. We'll do that point symmetric almost last. Axis of symmetry, remember we know it's -b over 2a, or since I already know this is the true factor form, halfway between -3 and -5 is -4. So that's dashed. So it's got to be somewhere along here. Okay. It opens up. This is A is positive, so we can do the opens up. Okay. If it opens up, it's a minimum, right? The y value is the lowest. Okay. The vertex, we already know it's got to be -4. Okay, because that's the midpoint of -3, -5. So that's what you would get if you did -b over 2a in the standard form. We would get -b is -8 over 2 is -4. So that's consistent. -4, axis of symmetry is x equals -4. Okay, so we know the x coordinate is on the vertex is on the axis of symmetry. So that's why we know it's -4. Now we're going to plug -4 in. Now, remember I said into the original that it gave me is right here. I'm not going to plug it into there because you might have messed that up and not multiplied correctly. This is correct right here. Remember, f of x is the same thing as y. So I plug in the x, multiply them together, and I get my y coordinate. So I'm going to now plug -4, because I know that's true. It's halfway between -3 and -5. I saw that, and I got that verified with the -b over 2a, gave me the -4. So I'm going to plug this -4 into the x. So I have -4 plus 3 and -4 plus 5. So 3 minus 4 is -1, and 5 minus 4 is +1. What's 1 times -1? -1. So the y coordinate is -1. -4 comma -1. So I told you I was going to show you in the last problem how I could plug it into the factored form. I forgot to, but since we're in factored form here, I just showed you here how you can plug it right into the factored form and get the y coordinate. So -4, -1 is right there. That's my vertex. I'll get rid of that so you can see it better. Okay, so I know my curve is coming like that through there. And remember, it's got to be, these are dashed because it's not really there. 90 degrees and the same distance. How far is that? 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4 right there. So it must come through like that with arrows on the end. There's the graph of my parabola. So now I can get that point symmetric to the y-intercept. There's my y-intercept. So here's that point symmetric to it, equidistant from the line of symmetry, perpendicular, and that is -8, negative, the y-intercept is 15, so -8, 15. Okay. Now, does that make sense? Is the x-coordinate or the line of symmetry halfway between the 0 and the -8? Yes, it is. Halfway between 0 and -8 is that -4. So that makes sense. I've got that point plotted correctly. So that's another way you can check that you didn't miscount. Remember, this axis of symmetry is halfway in between the y-intercept and the point symmetric to it. Same distance away, 4 away. All right. That is everyone answered on this example here. Okay. Well, let's go to the next example. This is called vertex form. This is the last of our 3 forms. So you have standard form, the ax squared plus bx plus c equals 0 or f of x. The factored form, in factoring, x minus a times an x minus b, for example. And now we have vertex form. Vertex form in function notation, I could always write y if I didn't write function notation, is a times the quantity x minus h squared plus k. The vertex itself equals h comma k. Okay. Now, if I look at this, I see x minus h. So if I have this problem right here, this really would be x minus what number gives me +1? Well, that'd be a -1. So h really is -1. Now, do I have to ask myself and set myself up like that each time? No. The easiest way to think about it is another word for negative or minus is opposite. So when I do this h, so when I have this problem, -2 x plus 1 squared plus 8, just think opposite, same. Okay. That's my vertex. Obviously, this is the x-coordinate because it's next to the x value, and then this is out by itself, the y. This really could have come from the other side. So another way, sometimes you'll see it's written as y minus k equals a times x minus h squared. That's not how we have it set up in ours, but that would be what would happen, right? If I move the k across the other side, it would become minus k, wouldn't it? So in this case, and that's why sometimes it's written like this, because then you can easily see that k is associated with the y coordinate, h is associated with the x coordinate right next to it. And in this case, it'd be opposite and opposite on both of them. Okay, because remember, negative is opposite. So in our problem, that would have said then y minus 8 equaled -2 times the quantity x plus 1 squared. And so the vertex would be the opposite and the opposite, -1 and +8. Okay, if it was written in this format. Okay, but ours, a lot of them are going to be written in this format right here. So if everything on one side, that's why it's then opposite and then same. Okay, because they move that k across the other side. So it's no longer opposite, it's the same. Okay, so vertex is -1, 8. So we plot that, -1, 8 right there, because there's a total of 10. -1, 8. Okay. What standard form? Okay, standard form now. I need to know my PEMDAS. Exponents come first, so I have to do this first, then multiplication, and lastly addition. So 1, 2, 3 is my order that I go in. PEMDAS. Okay, you got to know that. Order of operations. So we're going down. Okay, so we do x plus 1 squared. If you know the shortcut, you know it's x squared. You multiply the two terms together. That gives me 1x. Double that for 2x. And then square the last term, 1. If you can't remember that shortcut I've taught you throughout the year, then you need to multiply x plus 1 times x plus 1 and then do your double distributive property. Okay, and then you'll get that answer. Or you can do the vertical method as I've shown you at the beginning of the year. So next I'm doing distributive property. I'm doing the multiplication next. Okay, negative 2x squared minus 4x minus 2. Okay, I don't need parentheses around that now. And lastly, plus 8. So now I got to combine like terms, those two right there. So the final answer, negative 2x squared minus 4x plus 6 equals the f of x. Okay. Now, y-intercept. Here's where, remember I told you the y-intercept, you want to plug it back. You know it's 0, comma, whatever the y is going to end up being. So I'm just plug in 0. Where should I plug in 0? I could plug it into this f of x right here that I just found in the standard form, but the problem is, in doing that, what if I messed up my standard form? You did not multiply correctly, distribute correctly, add, combine like terms correctly, and get that. If I plug it into there, I'm going to get 0, 6. And if it's wrong, I'm going to be wrong with my y-intercept. So you always want to plug it back into something that you know is true for sure. What's true for sure is this. This was given to me. So I'm going to plug the 0 into there. 0 plus 1 squared times your negative 2. So 0 plus 1 is 1. 1 squared, remember order of operations, 1 squared is 1, times negative 2 is negative 2, plus 8 gives you my 6. Okay, so since I got 6 there and I got 6, if I plug 0 into the standard form, I would get 6 also. That probably tells me I did my standard form correctly, most likely. So 0, 6 is my y-intercept. 1, 2, 3, 4, 5, 6 right there. Okay. Now I want you to graph it. Okay. So if you haven't, I'm going to erase this right side over here. If you haven't written it all down or pause the video, I'm going to erase. So I'm going to, oh, dang it. Erase this. Okay. So now I'm going to show you how the easiest way to graph it. Okay. Without having to plug in points into X, Y into this entire thing. This is my vertex. Okay. What would be my A? My standard form right here, ax squared. Remember I told you that's the shape of the graph. So the shape of the graph is negative 2x squared. Okay. This is your ax squared right here. So what I'm going to do is I'm going to do plus or minus 1 and plus or minus 2. And I'm going to plug those in. Notice I'm putting plus or minus because I'm squaring that x squared. It doesn't matter whether I plug in 1 or negative 1. When I square it, I'm going to get the same number of 1 times negative 2 is negative 2. I plug in plus or minus 2 into the x, and I'm going to get 4 times negative 2 is negative 8. That's why I can put plus or minus 1, plus or minus 2. There, remember how we want 5 total points, the vertex and 2 on each side. Well, here's my 2 on each side right here. I already had the vertex. Notice it says plus 1. I'm starting from the vertex. This is like my new origin. And it says go plus 1 on the right, down 2. Right 1, down 2. Oh, there's my y-intercept right there. Go left 1, down 2. There's that point of symmetry across the y-intercept. Go right 2, down 8. Right there. Go left 2, down 8. Right there. So notice they come right out at negative 3, 0, and 1, 0. That means since they come right out at nice numbers, that means that this would factor, and we'll factor that in just a second for practice. This standard form would factor. It would come out to those points. So now I have my graph real quick. Right there and right there. Okay, if they happen to ask for the axis symmetry, I know it goes right through the vertex It's x equals the x-coordinate of the vertex, -1, right? Right there, if they wanted the axis of symmetry. But look how quick it is to graph. Remember, the shape of the graph is always your ax squared. So my x-coordinate, the y-coordinate is whatever I plug into that ax squared. Okay, and get that. This is how I would teach on graphing that. And so you really understand, and you can now know from the shape of the graph how to compare it, as we'll see, to other graphs. Okay, when we compare the equations. Now, I said since it came right nicely through at this point and this point, that means it factored. So we'll just practice factoring that just for the heck of it. Remember, I want my leading coefficient to be positive. So the GCF here is going to be -2. I want it to be positive. I'm taking out -2. I'm left with x squared plus, 2x, and then -3. I divide by -2 on each term. Okay, so notice then I get x and x. What multiplies the -3 and adds a 2? That's going to be 3 minus 1. And notice when I said each one equals 0, I get x equals -3 and x equals +1. Those 2 points right there. You didn't have to do that, but I'm just seeing that it went through that. That tells me that that's going to factor. So that would be another way to check to verify that I actually came up with a standard form. If it happens to go through 2 nice points like that from using the graphing right here, and it went through 2 nice integers on the x-axis, that tells me that if I did my standard form right, it would factor and give me those 2 answers, and we just tested that right there. We tested that, and it worked out beautifully. Okay, so those are the 3 different ways. Now we're going to look at some other just quicker questions and examples here that have been through the different packets, and you can see on the DCAS. That's why I'm doing it, because you can see that on the DCAS. Directions: use the following functions to find the best answer for numbers 1 through 3. Which function has the lowest minimum value? If it's a minimum value, these are all, notice these are all quadratics in the 3 different forms. We have the standard form, the vertex form, and the factored form. Those 3 different forms we just went over. Okay, the minimum value, that means it's going to be a parabola that opens up. And we want that y-coordinate. Remember, the y-coordinate is the one we're looking for. That's the minimum value, the y-coordinate of the vertex. Okay, so this is already in vertex form. We can see that right there. So it's going to be opposite, -4, -1. So what's the y value? -1 for that one. Okay, these other 2, we have to find the vertex. Okay, we know that gives me a -2 x-intercept and a -4 x-intercept. What's halfway in between that? What's the midpoint? -3. So x equals -3 is the x-coordinate of the vertex. Plug that -3 right into there. -3 plus 4 and -3 plus 2. -3 plus 4 is 1, and -3 plus 2 is -1. So the y equals -1. Right now, we have the exact same right there. Okay, for both of those right now. Here, remember to get the x-coordinate of the vertex, I'm not going to factor, I'm just going to go ahead and use the x-coordinate equals -b over 2a. So what is -b? -b is 8 over 2a. 2 times 4 is 8. So the x-coordinate is 1 there, so x equals 1. Plug that back in. 4 times 1 squared is 4, minus 8 is -4, plus 10 is 6. So that y value is 6. So which one is the lowest? These 2 are the same. G of x and h of x would be my answer right there. Okay, both of them have the minimum value of -1. Okay, now pause if you need to. Write anything is down and I'm going to erase. Okay, which function has the lowest y-intercept? Well, we know the y-intercept comes from making x equal to 0. We've already gone over that. So plug x equals 0, 0, 0. That one gives me 10. Plug in 0 here. 0 plus 4 is 4 times 4 squared is 16 times 2 is 32. Minus 1 is 31 for that one. Obviously, 10 is much lower than 31. We want the lowest. Plug in 0 for here. 0 plus 4 is 4. 0 plus 2 is 2. What's 4 times 2? 8 for its y value. So which one had the lowest? The 8 is the lowest here. That's the h of x. right there, C. Okay, you're going to have potential problems like this in the DCAS. That's why I'm added these in this review here. Okay, it may not be on your test, but it's going to be that way. You don't have to review it during the DCAS review. We've gone over it right here. All right, which function is the widest? Remember, the widest is when a is between -1 and 1. Well, that x times x is 1x squared, so that's a 1. This is a 2 for my a, so that's even narrower. And this is a 4, so that's even narrower. So which one's the widest? The one with the smallest of these numbers right here, because there is no decimals, no fractions between -1 and 1, which would make it wider. So 1 is the smallest between 1, 2, and 4. By the way, it doesn't matter if that was a -4. I'm not using the negative part. The negative just tells me it opens down. So let's say that was -4. 2, I wouldn't say, oh, what's the smallest number there? No. 1, it's really the smallest absolute value number. Okay? So the absolute value of -4 would be 4. Okay? The negative part just tells you that it opens down. Okay? So I said, which one is the widest? H of x, because its leading coefficient is the smallest. And a better answer would be the absolute value of its leading coefficient is the smallest. Because like I said, if that was a -4, -4 is smaller than 1, but that would not be the answer still, because the negative part just tells me it opens down. So it really should say that because the absolute value of the leading coefficient is the smallest. Okay? That'd be the absolute value of A right there. It's absolute value. Okay, let's see. You're going to have one like this in the DCAS. So be familiar with it. That's why I threw this on here. It says the computer's height. That's why it says h of t. H is just the name of the function. The reason they use h because it stands for the height. Whatever, this is my y value. Remember, this is the y value, h of t. You usually try to name the function by what it's dealing with. It's dealing with height, so they call it h of t. Remember, you usually see f of x because it stands for function. That's function notation. That's why they use f. But when you're talking about a real life sample, since you're dealing with h, height, you want to call it by that. That's how most functions are named, by the first letter of the key word in it, just so you know that. So as cost function, you'd see a C of t for cost. Okay, that's another common one you'll see. Height, it's in feet above the ground, so it tells you my units, that's feet. T is the seconds, so T stands for seconds, which is time, obviously. H, height, and that's in feet. After Mr. Kelly threw it, he threw the computer out the window. Okay. If you watch the Substitute movie, when the substitute teacher threw the student's radio out the window for playing his boombox out the window for playing it while he was trying to teach, and he told him to be quiet, and he wouldn't. So he said, we have an impasse here. I mean, something's got to give. So he took his boombox and threw it right out the window off the 2-story building. Okay. All right. How many seconds will it take the computer to reach its maximum height? Well, I know it's a quadratic, so I know it's a graph into a parabola. The A is negative, so I know it's opening down. And so where's its maximum height going to be? At the vertex. So another keyword, maximum, right there, we know it's going to open down to be a maximum. Now the maximum height. Now this x-coordinate, the x-axis is always time, always time. So this is going to be my seconds along here, and the y is the height. Okay, the y-axis is the height. So that's the y-coordinate. So we want the y-coordinate right here of that, and that's going to be the maximum height. We want the y-coordinate of the vertex. The x-coordinate is going to give me the time that it took to reach that maximum height. Okay, so t for time, and then plug that in, get the h of t, that's the actual height itself. So it occurs at the vertex. Okay, well, how do we get that vertex again? Remember, we know we do negative b over 2a, that's the x-coordinate. Get that x-coordinate and plug it into, or you can call it the t-coordinate here. T is the x here, using t's instead. Okay, so negative b, which is negative 40, over 2a, which is negative 8. Negative 40 divided by negative 8 is 5. So after 5 seconds, this is going to be 5 seconds here, it's going to reach its maximum height. Now plug that 5 in for the t's, and that will give me my y coordinate, which is the height. So 5 squared, you got to remember PEMDAS again, 5 squared is 25 times negative 4 is negative 100. 40 times 5 is 200, and plus 20. 200 minus 100 is 100, plus 20 is 120 feet. Remember, you got to put the units on there. So maximum height is 120 feet. There's my answer. And you will have a problem like this on the DCAS, guaranteed. It'll just be some other situation, but it'll be probably a negative one just like that thrown out. It's going to be the parabola going down and once its maximum height. Again, that's why I threw this on this review here. So it's also part of your review. You might not see this at all on your test, but okay, you're going to see it on the DCAS. Which of the following is true about the quadratic function? Well, I should recognize this in vertex form, and I do opposite and same. So the vertex is 4, 5. What does it open? It opens up, so I can just quickly draw that. Put that if I wanted to, 4, 5 for the vertex. So I just have a quick little shape of it. It has a maximum value. What is, when I say value, does this have a maximum value right here? No, it's a minimum value, so we can wipe out the maximum values. Now, the minimum value occurs at which coordinate? The x coordinate and the y coordinate. I've already said this over and over. It's the y coordinate. So minimum value at y equals 4? Nope, that's the x coordinate. Y value, minimum value, or the minimum value is y equals 5, the y coordinate. Okay, next, which of the following is true about the quadratic function? Again, we see opposite and same. Okay, so that's the vertex, because it's in vertex form. We know a is less than 0, so it opens down. Okay, so 4, 5. And the parent function, just so you know, is always f of x equals x squared, the general shape. So it is 2. Remember, I look at the absolute value. The negative part just tells me it opens down. So the a, even though the a is negative 2, okay, so the a is negative 2, so it tells me it opens down, but the shape of it is going to be 2x squared. So how does 2 compare to the 1x squared graph? The 2x squared graph is narrower, right? If it's going to be wider, it's got to be between negative 1 and 1, and we already went over that. So the parent function is always the 1x squared or negative 1x squared. Okay, that's the same shape. So it is not skinnier, it is wider. I mean, sorry, it is skinnier because it's narrower. Another word for narrower is skinnier. Okay, so you might see here they're using the word skinnier. On the DCAS, I might use narrower. Same thing. So negative 2 makes it skinnier than its parent function. Now this one says opens down, and that's correct because it's negative. This one says skinnier, which it is, and opens up. No, it's not, because the a is negative, so it opens down. So a is my answer. It's not wider, it's narrower, because 2 is a bigger number than 1. So it goes up faster, or in this case, down faster. Okay? Now we're just going to practice some real quick sample ones that you possibly could see on the DCAS. That's why I'm throwing them on here. I'm using this whole unit review of the quadratics is also a review for the DCAS, so you can watch this again, this video. It's going to be about an hour long, almost by the time I'm done. Okay, to review all your quadratics, everything you need to know about quadratics for the DCAS. Watch it over spring break again. Okay, it says identify the zeros. Remember, that means where it crosses the x-axis, negative 2 and 1, real quick. Negative 2 and 1, not a point, don't put parentheses there. Here, negative 3 and 3. Here, it only hits at negative 4, so I only have 1. Okay, it hits twice is what that means at negative 1. It's going to open down, so you know it's going to be negative out front. Which of the following is the graph of this? So now they give it to you in factored form. I know this is plus 1, and that's plus 5. So what do I see? X-intercepts at 1 and 5. 1 and 5 right there. This one's also 1 and 5. Oh, this is not, and this is not. So how do I know which one of those is? This one opens up, this one opens down. Well, what's my a here? When I do x times x, that's 1x squared times the 1 out front is 1x squared. So I'd have 1x squared. So a is 1, so it opens up, so it has to be b. Very simple. I'm just quickly going through this as a quick review now. Here we have vertex form, opposite and same, and it opens down. So we can wipe out the one that opens up right now. 112. That's negative 112. See, that's somebody who did same, same. This is 112 and this is 112. They're both 112. So now we got, and they're both opening down. So now the question is, which one is it? Well, we see it's negative 3. So 3 is narrower, right? Not wider. So when I go to the right one, see if I had x and then negative 3x squared, remember that's going to be the shape of the graph because the a is negative 3. If I went plus or minus 1, I plug that in there, I get down 3. So if I go right 1, that goes to 2. I should be going down 3 to, it's not quite there, it's at 9 right there. 12 minus 3 is 9, and that does hit right there. Left 1, down 3 right there. So that tells me it's that one right here. Notice if I went down right 1 here, I'm only going down 1. That's 11, not down 3. Okay, so again, there's how I can check that real quick. Okay. Another way, if you forget that, I could take and see this goes through at 3, 0, right? So if I plug in 3 for x, I have to get 0 for y. See if that's true. 3 minus 1 is 2. 2 squared is 4. Times negative 3 is negative 12. Plus 12 is 0. So that works. Okay, whereas this one was 4. And plugging 4 into there would not work. 4, you would not get 0. Okay, so that's just another way that you can check. So I'm giving you a couple of different ways that you can check if you're, because you might have a graph, you're going to have one of these on the DCAS. I just don't know which form they're going to give it to you in. That's why I'm having all 3 forms. Vertex form, and they say identify the graph. This one is factored form, identify the graph. Okay, it's going to have one of these. I just don't know which form you're going to get on the DCAS, so we're trying all 3 forms. Okay, here's another vertex form. Opens down. We have our vertex at opposite and same, 6, 9. Okay, so which one has a vertex? Which, oh, they all open down, so that negative 1 didn't help me. They all open down. Okay, vertex is 6, 9. That's 6, 9. That's 6, 9. That's 9, 6. And that's negative 6, 9. So now we're down to these two. Now the shape is negative 1. So that means right 1, down 1. But notice, if I did that, that might be like, oh, but that's not right 1. That's right 3 because it's going by 3s. So that went right 3, down 3. Okay, and that's not our rule. So if I plugged, see if I did that, x and negative x squared for the shape, I do plus or minus 1, I'm going to get minus 1. I should have only gone 1. At 3, I'm going to get negative 9. So if I go right 3, as it is here, I should have gone down 9, down to 0. So it tells me this is not the shape. See this one, I went right, this is a total of 3. I went right 3, and I went down 9, just like I'm supposed to right there, as it says. Or left 1, left 3, down 9. Okay, right there. Okay, so don't forget that ax squared tells you the shape of the graph. You can make your own little quick XYT chart, do plus or minus 1, plus or minus 2, or in this case 3 to see what works. Okay, you could have also plugged in the 9, 0. I know 9, 0 is supposed to work, so if I plug in 9 in there, I better get 0 there. 9 minus 6 is 3, squared is 9, times the negative 1 is negative 9, plus 9 is 0. So I'd be able to see that that one works. So the answer is D. Okay, how about here? X-intercepts, negative 2 and positive 4. There's negative 2 and positive 4. Negative 2, positive 4. That's not negative 2, positive 4. Negative 2, positive 4. This is a 1/4, so it opens up. You can't open down. So now we're down to these two. Okay, now remember 1/4 tells me it's going to be wider. So it shouldn't be a narrower one. So I'm pretty sure it's going to be that one right there. Okay. Now, if you happen to know a point and see a point, you could plug it in to see if it works. Okay. The other way is look at if I, since I see it going through negative 2 and negative 4, negative 2 and positive 4, I could look at halfway in between there. Okay, I could do that as well and get the axis of symmetry. The distance from 4 to -2 is 6. Divided by 2 is 3. So if I go back 3, it's going to be at 1. Okay, so I know the x-coordinate is 1. Okay, so now plug in 1 into there. I have 1/4 times, what's 1 plus 2? 3. What's 1 minus 4? -3. So that's -9 divided by 4 is -2.25. So which one is graphed at -2.25? This one right there, -2.25. That one right there is -3, or even maybe a little bit lower, -3. This is the one at -2.25. Okay, so I could take the midpoint of those x-intercepts, get the x-coordinate, as we did here, to get 1, plug in the 1 into the original equation, and get the y-coordinate, -2.25. Okay, so there's that one. Here we have -3, -6. Okay, that one's -4, so that one's off. That's -3. That one's -2, so that one's off. -3, -6, -3, -6, and it's 3 halves. So that's 1.5, so that's going to be a little bit wider. So this one looks a little bit wider, so it's a good chance it's that one right there. Okay, if I plug this in, that looks like -6, 0, okay, and -1, 0 as my x-intercepts. So here's a point that I can clearly see it looks on it. So I plug in -6 plus 3 is -3 squared is 9. 3, okay, so 9 times 3 halves is 27 halves, which is 13.5 minus 6. Okay, that one's not going to work. So it looks like it's not that one. So let's look at, we'd be able to see it's not that one, therefore. Okay, this is too wide because it should have been, if I plugged in -6, I should have got a positive value. See, here's -6, and notice that's going to be 7.5. Here's my -6, and this is up here at 7.5. There's 6 and there's 8. It hits up there at 7.5. So B is my answer right there. I got that point. Okay, if any of this is going quickly for you, you can always rewind and watch it again. All right, now write the quadratic function for each graph. Okay, we know it opens down. Okay, so we know it's negative. Okay, I can write it in vertex form, 1, 4. So I can say x minus 1, because that's the opposite, squared, and plus 4. Okay. Now, how do I know what A is? A is the one I got to figure out here. Well, I went right 1, down 1. If I'm going right 1, down 1, that's just a 1. Okay. So I know that right there. Write another one and be down 3 more right there. Okay. And then if you want to, you could test the point. You could put in 3 into here and you get 0, or -1 in there and you get 0. All right, here, again, it's opening down. So we know it's negative. We got to still see the A. The vertex is at -8. So that's going to be x plus 8, because remember, it's always the opposite, and then plus 4. Okay. Now, notice this is going by 2's. So if I go right 2, I'm going down how many? 4. Okay. So, -x squared and x, I'm assuming I'm going to go with the 1 here. If you aren't sure, you're going to plug in 1 and test it. So I do plus or minus 2. I plug that in there. I get 4 times -1 is -4. So if I go right 2, I should be going down 4. And that's what it is. So it's -1 for that A as well. Okay, here we got f of x. And we know it's positive because it opens up. Again, this went right 1, up 1. So I already know it's a 1 there. And x plus 5 would make it -5 for the x coordinate. And -4 is the same value for the y coordinate. So it would be that equation. Okay. 3 more and we're done. So I want to test with different ones than just 1 or -1. This is a plus. Okay, we have 1, so it's going to be x minus 1 for the x coordinate, and that's 9, so minus 9. Now the question is, notice if I go right 1, I went up 1, didn't I? Okay, and right 2 more, it'd be right total of 3, and it went up 8 more. Okay, so I'm looking at 1 there. Now, what's another way I could test that? I see it 4, 0 works. So if my answer is right, 4, if I plug in 4, I better get 0. Or if I plug in -2, I better get 0. So I plug in 4 there. 4 minus 1 is 3. Squared is 9. Times 1 is 9. Minus 9 is 0. So that tells you my A of 1 was correct. All right, here. Fx, I know it opens up, so it's plus. My vertex is -10, so that makes it plus 10. The y vertex, y coordinate of the vertex is -25. Okay. Again, I could test -5, 0 works. Okay. So let's say I'm not even going to try to guess what the A is. I'm going to show you how you can not guess and actually calculate A. So I know that point is -5, 0. So I plug -5 into this x. I have to get 0 for the y. So I'm going to put an A there. I'm going to solve for A. I'm plugging -5, and 10 minus 5 is 5 squared, and then minus 25. What is 5 squared? That's 25. Times A is 25A. And now I'm going to add the 25 across. I get 25. Divide by 25, and I get 1. So A is 1. Oops, 1. So the answer is 1. Let's try that same method again on this one. So you get one other try of practicing that. I know it's going to be plus because it opens up. Okay, 6, so that's -6 to make it positive 6, and -4. I know I can see that 4, 0 is an x-intercept. So I plug in 4 into there. I have to get 0 for the y. 4 minus 6 is -2. Squared is 4. Oops, that's just one minus right there. Add the 4 across, and I get 4a equals 4 divided by 4, and I get a equals 1. Okay, so a was 1 in this case as well. Okay, so that's just another way of coming up with the equation with from vertex form and plugging numbers in to solve for the A right there. All right, that's a huge review of all 3 sections, additional stuff that I've thrown in here, come up with the equations. You should be good to go on anything probably dealing with quadratics on the DCAS now. So again, you need to watch this over spring break so you have this down.